Yeah. I got my shirt and tie on because we're modeling. Everybody Vogue. Modeling graph sine and cosine part 2. Looking at day 2 now. Before we do, we got to show you the video of Max. What? Let's take a look. Taught him a new trick. Take a look. Taught him a new trick.
Ben. Good boy.
Yeah, best dog ever.
Good boy.
Best dog
Good
ever.
boy. Smart dog.
That was amazing. Thanks for watching. That was my dog Max. Okay, so this is actually the guided notes. Then we'll jump to homework 4 and then homework 3. So thanks for watching. And so we really want you to help you understand these harder modeling problems. There'll be one of these on the test. Let's see, events that are cyclic, such as seasonal variations in temperature, can be modeled with trig functions. Cool. So for example, the average temperature of Regina is hottest at 27 degrees Celsius on July 28th, and the coolest at negative 16 degrees on January 10th. So write the cosine equation for the graph. Okay, so wow, we can come up with a whole cosine equation just from that little information. We can. So first of all, we're looking at January 10th and July 28th. And so that means that the period, or the B value, is going to be 365 days. So that's 2 pi over 365. So that's the first thing to denote there. And so that's when we're doing our equation of cosine. So that's kind of the first part there. And then we have something else we have to include, which is the phase shift. And so we'll go ahead and put that in parentheses as well. There's like a phase shift. We'll talk about that in a bit. So there's the first part. Let's go for our amplitude and midline, right? Cool. Okay, so we're going for temperature, which is going to fluctuate up and down as we go from left to right for our time period. So think about it this way. Here's time, which is our x value. And then here is temperature, getting hotter or colder, and that's going to be our y value, right? Awesome. Okay, so let's take a look here. So we need to do some conversions. Well, first we can go ahead, let's see. So we can go ahead with our highest and lowest temperature. Cool. So to find the amplitude, we would go ahead, do you remember this part? So you got to memorize these formulas here. So it's the maximum minus the minimum, and that is a formula, right? Formula A. And so that's a formula all divided by 2. So our hottest is 27 degrees. Our coolest minus negative cold temperature, 16 degrees, all divided by 2. And so that's going to give us 7 and 6 is 13. Carry the 1. So is that 43, I think, divided by 2? I can double check there really quick with you there. So that's going to be 27 minus a negative 16. Good. And there we go. Yep, 43. Good. And so divided by 2 gives us an amplitude of 21.5. Cool. So again, that's our amplitude. Now the midline is also very, very similar. So the midline is actually, instead of minusing them, you're going to go ahead and average them together, combine them together. So that's going to be a maximum plus the minimum divided by 2. And so our maximum, again, is 27. This time we're going to add it with a negative 16. Interesting. And so then divide that by 2. And so 7 minus 6 is 1. 2 minus 1 is 1. So that's going to be 11 halves, which is going to go ahead and be 5.5 for our midline. And then we'll talk about our period and put it all together. Let's see here. So now we'll start to put it together. So our equation for part A, this is on your guided notes, that problem there, is going to be y equals the amplitude, which is 21.5, and then cosine, and then our period, which is 2 pi over our total number of days, our time period, which is 365 days. But then we're going to have to do x minus a phase shift, and so we'll talk about that in a second. And then plus the midline. And so the midline is 5.5. Nice. Okay, so for us to find that phase shift, it's basically going to be, so what is that number? So it's basically the, so it's the highest, so it's basically your maximum, right? Your highest point, your maximum, but it's the x value. So the highest point maximum is going to be what, 27 degrees. That's our y value. So basically we want our x value at 27 degrees. And so our x value is going to be June 28th. And so June 28th we have to put into numbers. And so in order to put that into numbers, we have to go through and add up all the days before it to get to June 28th. So think about that. So January, you'd say 31 days in January, plus 28 days in February, plus, what's after February? March, 31 more days. And then April, 30 days. May, 31 days. So January, February, March, April, May. And then June 28th, but only 28 days because we're going to stop there. So that's going to give us 179 days, okay? So if you think about it, if we're starting at 179 days, that is going to be our highest temperature, our hottest temperature. And so why are we choosing that, 179? Because think about the graph, which we'll do next in a second. So the graph wants to start off, so it'll be a phase shift at the highest point. And so if the highest point is 28 degrees, then we want to start off wherever that is. So let's say that's, June's kind of in the middle. So maybe it starts here, right? And since it's the highest point, then it goes down the lowest point and back to the highest point. So that means that at 179 days, that's where our cosine graph will start. And right there. And then that'll create cosine. So we want to shift over to 179, so we're at our highest temperature, and that's what we want to do for cosine. Cool. So we'll double check our answer because you have that. Do you see it on your guided notes, all the answers there? So that's how we found 21.5, our period 2 pi over 365, then 5.5 for the midline. 209, oh, did I make a mistake again, doggone it. So let's double check there. So 209 comes from, let's double check our calculations there. So 31 plus 28 plus 31 plus 30 plus 31 plus, let's see, 30 again, what? January, February, March, April, May, June, July. Does it say July 28th? I thought it was June. Highest temperature. Oh, there's 27 degrees. And it was actually not June. No. So it was July. Sorry about that. So we got to add another amount of days to it. And so it's not going to be, whoa. Let me undo that. Okay, so it's not going to be, fill in the blank there. So it's not going to be 179 at all. It's actually July 28th. It's okay to make mistakes because now we're learning. And everybody makes mistakes. Everybody has those days. So we're going to go back to our calculator there. And so we actually need to add June in there, which will be 30 more days. And then add the 28 from July. And so it's actually 209 is what that's going to be. So we'll go and erase that. And so it's actually not 179, it's 209 is going to be our phase shift there. Cool. So there's 209. Beautiful. And so that's going to be our function. There it is. Excellent. So phase shift with our trig functions is what part 2 is all about. Awesome. So then it's going to ask us to do a graph, our high and our low, which we already kind of showed you. So let's see if you got it right. You try it first. Don't look at your paper. Don't cheat. Okay, so you try it first. So again, our highest degrees was 27 degrees. I think our lowest was negative 16. And so then we cut that in half, and we got a midline of, what was it? 21, I think. Let me see here. So we had a midline of 5.5, and then amplitude of 21.5. So here's our midline. Oh, because we had to cut that in half, right? And so cutting that in half, you're way down here at 5.5 degrees. And that means you're splitting it up, right? You're splitting it up into 2 parts of your amplitude. So it's high, so up 21.5, down 21.5. Cool. Okay, so we're going to be starting on January, which is 1. And so then when we type January as 1, so then the day is 0, and then the maximum values with the positive cosine graph would begin on July 28th. Cool. Okay, so then we would start up there July 28th and add 1. And then we would go ahead and go all the way down to negative 16, and then back up again. And then excellent. There we go. And then we're going a distance of 365 days. Awesome. So there's our total number of days there with our phase shift. And let's see how we did. Don't forget to label. What should we label it? Oh, yeah. So go and label it. So we want to label it let's see. So we want to label it days. So this would be time. Time always goes on the bottom. And then this would be a temperature, right? So that would be temperature in what, Celsius? That's it. Cool. So days of the year. Okay, let's see how we did. Woo! Upside down. What the? No. Oh yeah, because why? Because we started off at the high point, which was what? At 209 days. So right about here. So 209 days, there we go, is our high point. And so that means that if we're going from there with our shift there, that means that we would start low and then reach that point, which is high, and then back down again. And it's upside down, phase shift. That's right, upside down. These phase shift things are tricky. So let's go ahead and show that to you. Let's see. So we go to our calculator, we go to y equals to show it. So 21.5, then we got cosine of 2 pi. You get to use your calculator on the test for this portion, don't you worry. So let's actually need to do a double parentheses there, really? Yep. So 2 pi, there we go, divided by 365, close parenthesis, open parenthesis, and then our days, x or d, minus 209, close parenthesis, close parenthesis again, and then plus 5.5. Cool. So this is the tricky part, is the window. A lot of you might be struggling still with that. So you got to think about it with our graph, okay? So think about your graph there with our window. And so I actually labeled this wrong because this would not be 0, like we said. Days was at 209 is at the high point. So that's why it should be way up here and comes down. But we'll show you on the calculator. Okay, so then we're going to do our window. So think about that. We want to go from 0 to 365 days. And then for our minimum, negative 16, maybe make it negative 18. So go a little bit less than the minimum and a little bit higher than the maximum. So that's how it helps us there. There it is. So it is going to be upside down. Wow. So it's going to be an upside down graph because of the phase shift. And so there's our top at 27, our maximum, 27 degrees at 209. So I messed up on my graph. Oh no. So if you do that during the test, just fix it. Just like look at the graph on the calculator, right? And then, oh, cool. And then just go in and fix it. So let's go in and fix it there. Okay. There we go. So then, what's your favorite color? Nice. Okay, so that's our high point, right? And so our high point is there, so that means we'll come back down this way. And that's what it did, and I think it even started to creep up a little bit there. And then it came down this way. Awesome. So we'll go ahead and look at our graph. Does that look a little bit similar? Yeah, a little bit better. Awesome. Okay, so there's our graph. And then, excellent. Okay, so then what is the average temperature expected for October 4th? So first, we have to find what October 4th is as an x value. Oh no. So we're going to go ahead and carry on all these, adding with all these months. So this goes to July, remember, July 28th. So if we change that to 31, plus 31 for August, plus 30 for September. So we have July, August, September, and then October 4th. So we're just going to add 4 now. So that gives you how many days? So October 4th is 277 days. So x equals, nice, 277 days. So now we're going to go back to our graph, and we're going to go ahead and look at the 277th day with our equation. So then we go to trace, and you can trace over to get to 277 days, or you can do x equals 277, right? So it's right about x equals 277 days there-ish, 13, a little bit lower. Let's do faster, go to second calc, right? Second equals, and then we can do option 1, which is value, and then we can go ahead and type in 277 days and get our exact temperature. So we expect to be 13.877. So our y value, our temperature, is 13.87 for our temperature there. So we could round that up to 0.88 if we're going to the nearest hundredths place. And then don't forget that's Celsius because that's degrees. So that's our answer there, 13.88. Yeah, did we get it? No. Oh. Wait, I think we did. 13.88, which they rounded up to 13.9. Sick. So you just plug 277 into the equation is what we just did there by using the graph. You could also plug it in like that or use the graph and go ahead and trace value. That's what I just taught you. 277 gives us 13.88. Cool. Okay, the average temperature is higher than 23 degrees for how many days? So now we're looking for 23 degrees on our graph, right? And so 23 degrees is up here. So maybe about, what do you think, about there? 23 degrees, let's take a look. So 23 degrees is about here. So we're looking for how many days was it that hot during the summertime? So we're basically looking for this region here, and how many days was it, right? So you can do that algebraically, which I kind of stink at, but I showed you on the other video and it went pretty well. But now we'll just go and use the graphing calculator. And so using our graphing calculator now, excellent. So we're going to go ahead and just find where 23 is. Ooh, let's do the Isaac Mortensen method. Isaac, name drop. So Isaac, we got you here because you helped us. He said something freaking cool. Do you remember second period? He said, why don't we just graph it 23 days and find the intersection? I was like, what? No way. He's like, yeah. So if we do trace, so right about there, so at 23 days, we have, at 23 degrees, not days, 23 degrees, we're on the 174.7 days. So he said we could do the intersection. Second calc, no way. Intersection, option 5. And so we can go first curve, second curve, enter. And so right at 23 degrees, it's 172.9, which rounds up to 173. So on the 173rd day, we start our degree temperature there. Of course, this is on average because it does fluctuate. So 173. Then we go back to our calculator and do the same thing, going over to where it says, right there, do intersection again. Why not? 23 again, 244th day. So second calc, and then we'll go to intersection, option 5, enter, enter, enter. And so that gives us approximately 245 days. So now we're going to go ahead and minus those two to get the actual thing. So 245 minus 173. And so when we go ahead and minus those, that'll give us the total number of days. Here we go. So 245 minus 173. So 72 days. Nice. Is that right? Let's take a look. There it is. 72 days is right. We nailed it. We nailed it. So thanks for watching this guided notes. We'll do the homework next. So again, we got 72 days. How did we get that again? We went ahead and figured out up here that it was 245 minus 173. Awesome. So 245 minus 173 gave us the total number of days. Right? Right. Awesome. Thanks for watching. And so we'll do the homework problem on the next video. So that was a good guided notes video to help you. So thanks for watching. Stay tuned for our next video to help you on the homework. Sick.